In last lesson, we were discussing every system that converts one form of energy to another form of energy is called a transducer. It can be a system, it can be an object, it can be a living organism like a human being. Humans convert chemical energy of food continuously, even if we do nothing. Even there is a resting human being, he will be producing heat energy to maintain the body temperature. For example, if you eat something in evening or near night, and then you do nothing and you sleep, and then you wake up in the morning after 8 hours and you start feeling hungry. Why? Well, you haven't done anything. You didn't use any of your energy, but still you're hungry. Why? What happened to the food that you ate last night? Actually, all that food is used, or most of that food is used to produce heat energy to maintain your body temperature. So even human being or living object can be transducers. Uh, Sometimes it becomes very difficult to distinguish between input and output of a particular transducer or machine. For example, if there is a lift, electric lift, that is used to shift people from one floor to another floor, so it will be a box filled with human beings which can go up and down. So on the top there will be a roller that spins, winds up the wire on top, and make the lift go up, and it can also make the lift come down. So there are people inside. So in this case, what will be the input form of energy and what will be the output form of energy? So when this lift is going up, smart lifts. When they go up, electrical energy is converted to gravitational potential energy. When they go down, gravitational potential energy is converted to kinetic energy, which is converted to electrical energy, which is stored in battery and then used next time when someone goes up. And this is how we can save electricity. This helps to save electricity cost is reduced. So this will be uh, an economical advantage. What will be environmental advantage? Less fuel
Fossil fossil
to
fuel
be.
turbines.
No, we need to burn less fuel to produce electricity. Less
Yeah.
fuel to be burned, hence better atmosphere. So this is how this becomes a smart system. So we convert uh, kinetic energy into electrical energy. Now, how many different ways we can produce electrical energy? Producing electricity. Now, if a physics teacher is insisting on that energy is created nor destroyed, law of conservation of energy is there. Energy is not increasing, not decreasing. Then why do people say that we are having some kind of energy crisis? There cannot be crisis of something which is not increasing or decreasing. So what do we mean when we say energy crisis? Actually, most of the time, when we are saying energy crisis, we are actually referring to either the fuel crisis or we are talking about electric energy crisis. If some areas or some countries or some cities or states they cannot produce enough electricity, then they say that we are having some energy crisis. And why electricity is so important? Because in the recent life we are so much dependent on electricity. Like we cook using electricity, we heat our homes using electricity, uh, we even travel with electricity these days. We are having hybrid electric cars and lifts and malls and shops and everywhere you see you find electricity working. Industry is working on electricity and everything. Therefore, we are very much dependent on electricity. Just guess this, like the whole paradigm of this earth will be different if electricity disappears from earth. Things will be very different. So what is the problem? Problem is that we still have same amount of energy everywhere, but we want to convert every energy to electrical energy. And this is where the problem comes in, that whenever we convert one form of energy to another form of energy, not all of the energy goes from one form to another. Some of the energy is always, it is like changing vessel of some liquid. When we put liquid from one vessel to another vessel, some liquid is always wasted. Even if we pour every single drop, some liquid will still stay in the first container. So some of the liquid is always wasted. Similarly, whenever we convert energy from one form to another form, some energy is always gone into the form that we don't need. So this is what we is people are referring to when they're saying we are having some energy crisis. Now, how do we produce electricity? Actually, rotational kinetic energy used to spin generator. Generator produces electricity. Now, that is very simple. This is what we need, rotation. Once we have rotation, we we can spin a generator, the coil in a generator. Once the coil in a generator is spun, electricity is produced. Now, this is where the turbine comes in. We use turbine. What is a turbine? Any okay, I guess my connection was lost for a second. Now, let me know. Were you with me when I was saying the word turbine is?
Yes, sir.
Okay, what is a turbine? Any mechanism or any system that can convert linear motion into uh, rotation is called turbine. Okay, you must have heard wind turbine.
Yes, sir.
What is a wind turbine? So it is a big fan looking thing. Okay. So what happens is that when air goes through, which is moving in a straight line, the turbine converts it into rotation. And once it starts to rotate, we have electricity. Secondly, if there is a stream of water, and this is a very common scene in villages. If some of you have any experience of a village, you might find it there. This is a wheel, a large wheel, which is pivoted at the center, and there is water flowing here. So there is a stream of water going like this. So what happens when water is flowing like this? It will make the wheel spin. So this is also an example of turbine because it is converting linear motion into circular motion. And there can be so many possibilities. Anything that converts linear motion into circular motion is called turbine. Now, how to rotate turbine? So what we can use to rotate turbine? So most common thing is source is high pressure steam. So we use what? High pressure steam. Second, uh, flow of water from dam or flow of air by windmill. Okay, they can be so many ways. So let's discuss these three because they are connected to our syllabus. We can use what? High pressure, steam. We can use the flow of water. We first store water in a in a high altitude behind a wall. We call it dam. And when water flows through a chute down the stream, it gains kinetic energy. So when it goes through the turbine, it makes the turbine move. So this is how we can make a turbine rotate. And we can also use air, flow of air, which is also used to make turbine move. Let's come to the steam. So here we have water. So water needs heat. So what provides heat to water? So how many different ways we can provide heat to water? This heat can come from burning coal or fossil fuel. This heat can come from nuclear reactor. This heat can come from, this heat can also come from geothermal energy. This heat can come from uh, geothermal, nuclear, burning fuel, and what else can produce heat energy that big? Burning biofuel. Okay. So we can use any of these to produce heat energy. That heat energy goes into water that produces what? High pressure steam, which goes into what? Turbine. Turbine converts it into rotation.
which is kinetic energy, right, sir?
Turbine converts the high pressure steam, the kinetic energy of the high pressure steam into rotation. That rotation goes into generator. And that generator produces electricity. So try to understand like all those methods that use heat energy, that heat energy can come from any source. It can come from burning coal. It can come from nuclear reactor. It can come from geothermal energy. We can use the heat energy of the core of Earth. Core of Earth is extremely hot, and we can use that energy to produce steam, and that steam can be used to produce electricity. So all these sources, they produce heat energy. That heat goes into the water. Water converts into steam. Steam goes through the turbine. Turbine rotates, produce electricity. Is that clear? Anybody confused?
No, sir.
No, sir.
Good. Now, how is electricity produced in hydroelectric power plant? Let's see, this is water level. This is dam. Now, a question. Why dam walls are made thicker at the base than at the top?
There's more pressure at the bottom.
Yes. As we go deeper into the liquid, we get more pressure. So the lower side of the wall has to take care of more pressure. That's why the lower part of the wall has to be more thick. Now what we do is we make chutes. Now water comes out through these pipes. So what happens when water comes down? Gravitational potential energy of water is converted into kinetic energy. So water's gravitational potential energy decreases and the kinetic energy of the water increases. So water is coming down. Now on the way, there is a turbine. Water flows through the turbine and it goes into the streams and rivers, which finally end up in seas. Like on the way, when it goes towards sea, on the way it is used for agriculture. Okay, this is one good thing about hydroelectric power station, that they also help grow agriculture. Listen, this is where turbine is producing rotation. This is turbine. This is turbine. It produces rotation. So mechanical energy goes into generator, and then generator produces electric energy. So this is one method of producing electricity which does not involve any burning, any damage to the atmosphere. Okay, I believe that dams occupy a huge space. They kill the landscape, but they are not harmful. They don't harm the atmosphere. That is a good thing about hydroelectric power stations. They're completely harmless. So generator produces electricity, and this is how, without burning anything, without producing any heat energy, without damaging atmosphere, we can produce electricity. But the question is that why it is said to be a renewable source of energy? What will happen when the water level will go down? There will be no water to come through the chute. So who puts the water back over there? Answer is the sun comes in action. This is sun. So sun throws heat energy on the water. That makes evaporation, which cause what? Formation of
Clouds and rain.
clouds. And those clouds move around. Some of the clouds end up producing rain on the dams and behind the dam. In areas that are higher than the dam, when rain falls over there, the runoff of rain comes into the dam and accumulates over there, and the dams are filled again. Okay. So, moving on, windmills are simple. They simply produce electricity when air flows through them. The kinetic energy of the wind is used to make the kinetic energy of the wind turbine, and kinetic energy of the wind turbine becomes the kinetic energy of the generator, and generator's kinetic energy converts into electrical energy. That is simple. Now, अच्छा जी, what is power? Rate of work done is called power. Power equals to work done divided by time. P equals to work done over T. Units. What is the unit?
Sir, I can't hear you, sir.
Can you hear me now?
Yes, sir.
Yes.
Okay. The power is work done divided by time. Unit for work done is joule. Unit for time is second, and it is a must. We cannot put minutes or hours over here. It will always be seconds. So power is joules per second, which is also known as watt. Question. What is 1 watt? Answer. If a work of 1 joule is done in 1 second, a power of 1 watt is developed. So if a work of 1 joule is done in 1 second, a power of 1 watt is developed. Now, question. An energy saver is rated as 20 watt. What does this mean? Like I buy an energy saver. For example, this is a box, an energy saver comes in. Okay, so there will be an energy saver drawn over here. Okay. And on the box, there is a thing written 20 watt. So what does that mean? If this is an energy saver, it is rated as 20 watt. What does that mean? Answer is this means that this particular energy saver converts 20 joule of electrical energy to light and heat in 1 second. So when we have an energy saver that rated as 20 watt, it means it converts 20 joule of energy from electric form to heat and light. Similarly, if we have a generator rated as 5,000 watts. If we have a generator of 5,000 watt, what does that mean? An electric generator is rated an electric generator is rated as 5,000 watts. If this generator works with fossil fuel what does 5000 watt mean? So generator overall converts chemical energy to electrical energy. And on the side dish, we produce sound and heat as well. This generator converts 5000 joule of chemical energy to heat and sound every second. Okay. I
Okay.
missed. I missed electricity. Actually, I mentioned the two waste form of energy, but I forgot the electricity. Energy to electricity and heat and sound. So in this case, heat and sound are the form of energy that we don't buy the generator for. We don't turn on generator because we are feeling cold. We turn on a heater for that. So generator, we turn on a generator when we need electricity. We don't want to turn on a generator when we need to hear a sound. So sound, we don't need sound, so that is wasted energy. We don't need heat, so that is wasted energy. But the useful energy will be electrical energy that we get out of the generator. Okay. So efficiency. Remember that we did a formula for efficiency using energy. We can similarly use power for efficiency as well. Useful output power divided by total input power. And if we need a percentage efficiency, there will be same formula. Efficiency or percentage efficiency will be the same formula multiplied by 100. So if we need percentage efficiency, we use the efficiency and we multiply it with 100. That will give us percentage efficiency. Formulas for power. Power equals to work done divided by time power equals to energy converted divided by time. And power is also electric voltage. Let's say electric power. Power equals to voltage multiplied by current. P equals to VI. You don't need know this thing yet. In future, when we will be doing electricity, we will do this. But till then, you have to remember that the power equals to voltage into current. If the data for voltage and current is given, you can use that to find out power. So that's it for today. We will resume from the same point tomorrow. Thank you very much.
Allah Hafiz, sir.
Allah, sir.
Allah Hafiz, everybody.